Hello there. In this video, we're going to talk about baulking in the Ciw Python package. So basically what baulking is if you have a customer that is attempting to enter a node, you can have a kind of gatekeeping mechanism that can say, no, actually, you're not entering the queue. So customers can be rejected from the queue, or similarly, if you're thinking about other kinds of networks like telecom networks, that packets can be dropped at some rate, and you may want to capture that things don't even quite make it onto the queue, even if they're sent. There's different ways to do that, of course, but this is one of the ways you can do it, so it may be worth understanding. Let's get into it. So Ciw provides the ability to just provide a function in the right place. So let's consider a single class network, and we'll start with defining the kind of function that's actually expected. So we can call this really whatever we like according to Python programming names. But the first argument here is going to be an integer, and it is the number. Actually, maybe let's cut to some doc strings here. That n is the number of customers in the queue of the next node. So that's going to be an integer, specifically a positive integer or a non-negative integer, I should say. And it also takes an argument q, which is going to be a q.simulation object. I should probably just get my type annotations to not be too annoyed at me. Simulation, that is just a spelling problem. Okay. So we got simulation, and that is a q simulation object. As we've seen in many times in previous videos, if you followed along, that we define these all the time. Maybe instance. And let's see what's next. The next thing we need to put in is the, next ind, which is the q.individual. And it's literally the next individual that's going to be served. I'm just going to create some spacing for our reading here, since we're being a little bit more verbose than the documentation by specifying types and such. The next ind is we'll say candidate customer to maybe join the queue. Should probably think about how to name that, but anyway, next individual is what we got there. Next up is, and actually the last argument we need to provide here is which node is the target node that the individual might enter. And that's going to be of type node. So next node the customer might enter. And for the kind of return type of this is actually a probability. So while the name probability in the name of this function is optional, it actually does need to be a probability in the mathematics sense. So that's not an integer unless it's a special case of 0 and 1, which really reduces to like Boolean decision type of function, but you can have values in between, so it can be a float. Now it's complaining in the type system here because we actually haven't written any logic. So let's write an example. We're going to pick the simple example from the documentation that actually only uses n. But in principle, if you wanted to use the simulation object, if you wanted to use the individual properties, if you wanted to have the properties of the node itself all be considered in this probability, then you can do that. So let's do the simple thing here. Let's say that n is strictly less than 3, so 0, 1, 2, 3, then there is a 0% probability of baulking, of being rejected at this node. Now, if n is less than 7, then return that it's like a 50-50 coin flip, and then otherwise return 1.0, meaning 100% probability of baulking. Okay. Now they show an example in the docs here that involves like a single class network, which is kind of unusual, but let's see here. Q.create network. and they give us that the arrival distributions they call it class. In fact, I'm going to just put small case class. And for that class, we'll define the arrival distributions. Here, there's only one. It's going to be a single node network. Follows an exponential distribution with a rate of 5. All right. And then for the service distribution, I'm just going to copy this over and maybe change a couple of things. We'll change this to a rate of 6. Now here's where we put in something new, right? Baulking functions, for which this is broken down by class, because this is kind of a class-defined simulation. So you would define for each node a probability function. That's a list. That's inside of dictionary. Okay, and then we'll just say the number of servers in this network is just 1 at the one place. Now let's run the simulation. So let's make a if name is under main. Then we'll set q.seed 0 just for reproducibility. This should all be very familiar if you followed along with the videos, but I just like to occasionally go through all the motions here. It's good practice. And let's gather our records. So we grab our simulation object and get all records. Now in the docs, they actually filter the records by whether they're bulked. Do I actually want to do that? Bulked records. I mean, honestly, this tool should be able to tell you to get only what you want. So let's just do that. Let's just go only equals a list and bulk. I think this should be equivalent to the list comprehension that they've got. And we can, you know what? Let's just print those records. Just print them. Just print them. So let's take a look how to simulate bulking. Empty. I think we did something not entirely correct. We forgot to actually run the simulation. You know, that's actually a pretty big oversight, is if you want results out of your simulation, you do need to actually run the simulation. All right. Skipped a line there. So we got plenty of records. All of these should have record type of bulk, and that should be fine. Is there anything we want to capture out of this? I mean, we could take a look at one of those records, I guess, just for simplicity, because that's a lot of stuff going on there. Caps lock. Caps lock gets me every time, and it's a bad place on the Kinesis Advantage where I often hit it when I actually very rarely want caps lock. I should probably actually, just for my own sanity, I should turn it off, because I honestly don't use caps lock really all that often. I'm more likely to write something out holding on to shift, or to type it out small case and then in NeoVim do like the case switch. Let me show you what I mean. Like I could take this line here and just all caps it like that, or I can undo that easily, select whatever text I want. Anyway, so there's a single record We got our record type is Baulking, meaning that they were rejected. They were not accepted into this node. Not that it matters, but I guess they made it past the meaning of life number, so that's good for them, I guess, but didn't quite make it in. All right. Anyway, jokes aside, that is using Baulking. Very simple, very straightforward. Really, this is the key idea here. Write this function for the type of Baulking you want at a given node. And yeah, good luck with writing your next simulation. And if Baulking is helpful to you, then all the better. Have a great day.